Hello guys, welcome back. Today we're going to be design the banking system. Majorly we'll focus on the fraud detection. What does mean by fraud detection? How it works? Which microservices we will need in the entire banking systems? We're going to be discuss entire process and we'll build the one best banking system application which can scale in multiple large scale database. So as you are following my series, you will know the set of steps we follow in this any system design video. I will not going to cover all of these steps. We'll just focus on the design and architecture parts. As you know, if you are following my if interview and the playlist which I already taught, so you'll get to know how you're going to be ask the question to the interviewer and all of things. So yeah, we'll start very first things. Uh, I will just written down the things you have to ask the interviewer. So you must have to require ask the requirement. Then once you complete the requirement, you have the functional requirement as well as non-functional require. You must have to ask them. Then we're going to be cover the core concept which called the database schema. Will talk on the schema. Once we discuss the schema and all of this, we'll build the API. Once we build the API, you don't have to build a all API. You just have to build some API. Let's see, in banking system you must have to discuss on the some banking API, just like payment transaction API, some create account API, some profiles, then check payments API, some all some APIs, which is most important in the requirements, which fulfill the requirements, functional requirements. So based on that, you must have to write the APIs and with the some logic which you are going to be add in the API. Once you are done with the API, we're going to design the systems. Once we done the designing part, we'll let the deep down the things, deep down the any service. We'll ask interviewer what exactly they wanted to out of this high level design interview, and they what they actual want and which part they are looking forward to scale basically. So that part based on the interviewer will going to be asked for the interviewers as well, and then based on that his sentiments, uh, his thinking, and we're going to be deep down that particular thing. Okay, so as you follow my last video, you'll get to know how we do such a kind of things, and it's proper manner it in very simple words. I'm doing like this, and I do um, crack lot of system design interview as well. Okay, so let's start with the our banking fraud detection uh, service. It's basically a little bit service, but we will design entire system because to understand the fraud detection systems, we must need the entire banking application as well. Okay, so let's start with the very first things. Um, uh, let's talk about the users. We have the clients. Let's see, we have the clients, and we'll talk them as a user. Once we have the user will call the API gateway. As I already said, this kind of architecture for every system design must have to talk. This will be the gateway, API gateway. Okay, so I will write like this. Based on this, okay, we have the API gateway. Once we have the API gateway, we're going to be distribute our API gateway with the different microservices. Let's see, we have the account service where we have kept the all details, and what we can say, account service is majorly focused on the user data. like create, update, and whatever the users wanted to do, they can do out of that service. Then we have major and important service which called the payment service, which will capture the entire payment process like payment transaction. Will called as the payment TXN, which majorly do the care of the payment transfer payment check and all of these things. Okay. And next, I would say other service will be the in payment banking application. We have a lot of things in the system. Sometime we onboard some external configuration, like so we'll integrate with third party like Razorpay, Pay slash Paytm. In India, we mostly use a Paytm. Then a lot. Such a kind of integration we can have in this service. Okay, once we done these things, we have different microservices. You can add the more into this, but I think this is pretty much for this banking system and fraud detection system. Okay, once we done this, we must have to add one protection layer, one asynchronous layer. I'll use the Kafka in between of the e-service to discuss to talk with our fraud detection service. Once we have the Kafka, once we have, we must need the important part which will going to be discussed today, which is called the fraud detection service. Fraud detection service. Detection service, which is important. Then we have the balance service. Balance your bank account basically, which will going to be bank account, which will going to be other ones bank account, not ours, like receiver's bank account. I would say I will write over here. This will be the receiver bank account. Okay, so this will like this receiver bank account. And one more thing, one more microservices we want. Uh, I would say validation, and we may have one more service which we require. So I would say blocked gate- block rule, which will going to be decide the whether we have to block the account or not. Majorly for once we detected the fraud, and based on that we'll see the whether we have to um, block the particular account or not. So this will be the other service, because we are defined the large scale application, so we must have to follow some certain rules and single responsibility principle. We have the some standard principles, as you guys know. We have the solid principle. We must have to follow that particular principle. So I will going to be follow that particular thing. Okay, once we have these microservices, we need the notification microservices for the notifying the users as well as customers, sender as well as fine, notify service. Okay, once we have the notify service, we'll connect this notify. We mostly going to be consume the event from the Kafka. So that's why I'm doing like this. That might be the two way of the things we may sometime consume the event only, and sometime we can send the event from this service as well, and this service must send the event to the Kafka, and they may consume the particular event as well. Okay, so this is like this thing. Okay, so I will explain the entire flow. Now I am just building the architectures and stuffs basically. Okay, so this will be like this. Now I will go through the entire flow. So once we have the user will request to the API gateway. As you know, every request, every REST request should go the API gateway. So it's a universal, what we can say, universal architecture. We do have an entire big top MNCs follow this. So definitely we're going to be use the API gateway. Once we get the API, based on that we do have the some rate limiting over there and a lot things over there. Based on that we'll go decide to which service we wanted to go do, like create account and all service. So this will be the for the basic integration and all of the onboarding and all of the this both service will be that. So major thing is the payment transaction. Once the user wanted to do a payment transfer will look the things. Okay, once we have the payment transaction, we receive the payment transaction. So each service have the it independent database. What I'm saying, independent database, DB. So each service have the independent database. Okay. So my payment system will be the independent database, and I will trigger the event like this. I will trigger the event, and each event may contain event payment slash payment. Okay, so this I will add into the payments and event. So I think I don't know why it is not looking. So this can be put. Yeah. Okay. So like this, I will add the event over there, which will going to be payment event payment. So basically, on that basis, my fraud detection service will capture particular event this, and once the fraud detection fraud detection service capture, and if he found some problem in that, so event will trigger, my fraud detection service will trigger one event and send to the Kafka, which called as the uh, scam found event. Based on that, once the event is triggered and which store in the Kafka, my notification validation service will consume that, and which and block rule will consume that particular event. At that moment my a bank account also consume that particular event, and will think, do we need to proceed that particular amount or not, because once the once we found some scam in that particular account, will going to be uh, restrict that particular payment or transaction, and will decide whether we have to block that particular account, or some hackers are trying to be do the transaction with the behalf of the user. So that's what we are looking. So these all service will be going to be receive this particular event which we have triggered scam. So based on this will validate everything and notify the service, notification service to users, whether the someone is trying to get the balance without your authority. So this will consume particular block, and this service will also send a send a notification to the Kafka as well to uh, consume particular subscribe Kafka to subscriber. Let's see, user also subscribe particular events, and he are looking for the payment, whether the payment status. So we generally do not do the API pooling. So we generally do send the event to the subscriber as well. So this will also the send event to the Kafka, and our will get that particular event. So now this is the something we are do the fraud detection service. This is the important service. We can add the cluster over here for the fraud detection. If we have the large use of people, so we can add the fraud detection service 1, then service 2, then service 3, like this. Okay, so I will not going to do this because this is pretty much understandable. You can create the clusters, you know the architecture and everything. Okay, so I know you guys are smart enough to understand this. Now my second thing is important. Once we have this architecture, and now we wanted to do little bit deep down with these things. So what happen if my definitely interview will ask you what happened my if suppose my Kafka is not able to consume the events, what happened? So our entire flow will be the down. If we think we do have we have the single Kafka. So basically in Kafka we do have the, I will write the little bit bigger view of the Kafka. We do have the Kafka box which contain the topics. We have the topic 1, then we have the topic 2, then topic 3. So basically, I will just copy this, copy, then paste, then paste, then paste, then paste. We have the multiple topic in topic over there, and we do have the multiple broker as well. So we'll name this. Okay, so we have the multiple brokers, and we each broker have the different partition as well. So I would say this is a partition 1, partition 2, partition 2, and partition 3. Okay, so and my broker will be the like B1, B2, B3, B1, B2, 3, B3. So I will draw the line for the B1. So B1 will target the his he's writing things in the P1 partition 1. So this each broker writing node will be the P1. For the B2 writing node will be the P2. Then for the B3 writing node will be the P3, like this, blah blah. So it's two round robin algorithm internally used. So will scale this accordingly our Kafka like this. Okay, but this is pretty much once you have the large broker, so you're not going to be down, your Kafka will not going to be down in any time. Okay, this is the solution for the horizontal killing of the Kafka. So you can tell the interviewer like this. But now next question will ask, interview will ask you, what does user send same request two time? Let's see. Uh, someone click your mobile is slow, little bit slow, and you are typing two time pins and doing the same transaction at the two time. So what will happen? And does Kafka guarantees to consume the single uh, event particular things? Let's say my payment is triggered one event, and Kafka may crash or some happen. So it is something that you are sure about the is event is the unique or not. So in that case you must have to talk the event id and idempotent. So this is the importance. We generally what do we kept the item in the idempotent event id, then we post the status or any. It's basically based on the coder and based on the company, they kept the idempotent key just like event ID and status. So we get to know the what exactly that particular payment status. So we'll get based on these idempotent ID. So based on the idempotent ID, we'll get to know whether we have the one request at a time. So we're not going to do the multiple time. Let's see, in our Kafka, we send one we send the um, one notification to the Kafka, but Kafka doesn't uh, Kafka consume that particular event, but Kafka doesn't acknowledgement to the service whether we get that event or not. So what happen? Service will be trying to be send same event again and again. So like this, but our Kafka is consuming the event. So this means it already consumed. So that time we use the idempotent event over there, idempotent ID over there to verify the event is unique or not. So this is how we can explain the interview. Okay. So next part will be the next question will be the event interviewer may ask you, if suppose okay, so next question will be interview might be asked you, suppose some event which is consumer trying to consume that particular event, but they are failing again and again. So does Kafka or does consumer will consume that particular event or not? So let's see, in this scenario, let's I will write the pencil, I had the pencil. Okay, so one transaction started from this. Okay, let me change the color. Well, take this one. Okay, okay. Now one transaction happen. Oh, let me start. Transaction happen, and now we send the transaction to the Kafka via the event. Okay, and my fraud detection service trying to consume that particular um, event. Now this event is not good. Means something is wrong with that event, not good, or wrong event have some problem or some stuff. Okay, so that time what happened in our Kafka, each service have its own offset. You must have no if you are new with the offset. So offset is just like key of the consume particular event. Let's see, in this case I will show you in this partition how the multiple events like e1, e2, e3, and blah 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 blah, so that which event he particular service is consumed or not consumed. To track that, each service have the offsets value. So offset value might be the index like 0, 1, 2, 3. If my fraud detection service capture 3 events, so its offset value will be the 3, like this. So that's called the offset. So it have the offset and it trying to be consume, and how they consume it, consume based on the series sequence. Like any consumer will consume first one, first 0, then 1, then 2, then 3. So before we complete the third event, it will not consume the fourth event. So this is how consumer can work. So what happen if you are trying to consume particular event again and again, so your fraud detection service will be going to be busy at any time, the service will going to be busy, so no use. So now next thing will not happen like bank account rule validation and notification service. Nothing is happen because we are dependent of this service. So once he completed the service, we'll send that particular event to the Kafka, and then this other event will other services will capturing that. But our this service is down. This is services consume this particular event again and again. So that time we have the algorithm which called as the do later tree. What we have the do later tree. So what it does, it try to consume particular event at a certain time of period. Let's say it 5 minutes, five times, 6 times, or 7 times. Once we found, we try to consume that particular, we are not doing that particular thing. So what we do is we do that particular event and store that particular event in DLT or DLQ. So this will be the date due later queue. Basically, this will be store particular event in that. So manually we do check that particular event, why this happening and why wrong with that particular event, and based on that we do solve that particular problem, so that our service will not going to be stop any case, and he will do his work properly rather than stucking at particular stage. Okay, so this is how we do the problem of the problem of the wrong event or miss event or retry event. So that called the retry mechanism, or we retry DLQ mechanism. Or so this is how we solve the problem. Or we also have the pro- circuit breaker as well. So this is the how we circuit breaker problem is something else, but this is the similar things does in the real application. But now you have this and you understand the what I mean to say. Okay, this is the pretty much about the fraud detection banking system. This architecture is more scalable, so you can scale and you can discuss the database as well. But I think so this is enough for the day. Thank you so much.